Morning, sir.
Today we are going to discuss a topic, case study topic, okay, which is a NASA or a SpaceX CR7, which is a structural failure has happened earlier. So based on that, what is the background of the failure? We are going to discuss. Okay, here my students are there. Your name please, just introduce yourself.
So let me introduce myself to you. I am Kartika Batra, second year.
We are second year aerospace. Myself, Manadi from second year aerospace.
I'm Davani from second year aerospace.
I'm Harshita from second year aerospace.
So based on the case study topic, now you are going to explain, you are going to expose what are the background points behind the failure. Okay, so start with one by one. It's your wish. We are whatever the points you are taking. It is your point. Randomly can talk. Okay. Let's start.
Good morning, sir. Today I'll be explaining the SpaceX CRS-7's mission overview. So generally it was launched on June 28, 2015 under the NASA's resupply service program. It is in international American program under the NASA's. The main objective of the mission is to transport cargoes to the ISS, International Space Center, Space Station. The main thing is what are the cargoes scientific experiment and supplies will be carried out through that. The missions will be carrying under the Falcon 9 rocket and the Dragon capsule. So Falcon 9 rocket payload also contain future docking adapters. So docking adapter which will be carried out from here to the space ISS, and the future crew missions will be docking through the station through that adapter. So its main role is SpaceX is to support the ISS.
Good morning, sir. I'm here to explain what actually happened. Just after 139 seconds after liftoff, the rocket exploded in the mid-air. It is due to structural failure. The strut holding helium tank ruptured, and which causes over-pressurization of liquid oxygen, which generally caused the explosion. During investigation, the investigators found that the strut holding that helium tank was not made under aerospace grades, which generally caused this explosion.
Anybody?
Good morning, sir. Let me talk about the impact due to this failure. Because of this failure, more than 4,000 pounds of cargo, including food, equipment, and student experiments, were lost. And this causes to delay the future launches and missions. And it also affected the ISS supply chain for some time. And this makes NASA has to change to resupply supply chain, and this affected the whole mission. So overall, this one failure has highlighted the over future launches and missions and mission teams.
Okay. Next,
So good morning, sir. I'm here to tell the lessons learned. So in response to the failure, SpaceX implemented stricter quality control measures, and they began testing all the critical components individually, including the struts. So they also upgraded the Dragon capsule software, which allows to parachute deployment in case of separation from the rocket during the future missions. So this improved the SpaceX transparency, and it regained the NASA's trust.
okay, nice.
So good morning to everyone. I am going to sum up the whole case study. So what I have observed is that the CRS-7 mission was not as important as other SpaceX missions, but it was very important for the company's growth. Though this mission has some flaws in their design and safety checks, but it also led the SpaceX to have their mission more safer and better. This also led to the idea of SpaceX that fail faster and learn faster. And this also helped the SpaceX company to work with the astronauts and work closely with NASA. Thank you.
So the precautions for the CS7 testing is we can use the high grade components of aerospace inside the aerospace strut. Such type of component can be used under the certification, and it can be checked using the quality assurance.
so that the structural damage can be avoided.
Avoided.
It may be one of the precautions can be taken.
Yes, sir. One of the
Maybe any other piece.
So the failure highlighted the dangers of using industrial grade components for high risk aerospace systems. So this made the SpaceX to improve its transparency and also improve its failure analysis method.
Okay.
So we can also use non-destructive testing methods like ultrasonic testing or X-ray to detect hidden flaws.
Yeah, non-destructive testing. So many methods, and then here you have to identify are the hidden material flaws are available so that the structural damage can be avoided. Okay, nice discussion we have done. So we can come to another topic with case study video. Okay, in the next session. Thank you all.
Thank
Thank
you,
you,
sir.
sir.